4 to the right on the first one, your answer should be 742, 000. Did you get that? Good. Don't forget the comma in there. And then this one would be 0.061. Yeah, you got that? And then this one should be 371.4. Good on these? Okay, rate yourself on how well you're understanding this part so far, 1 through 5. Feeling pretty good? So I want you guys just to peek. We're gonna just do a quick glance. Look at your homework. Can you guys see which ones follow those examples? That example from your homework. See, 1 through 3 follow that example. So you'll have, so you can see what to follow. Okay, so that was going from scientific to standard. Now we're gonna go the other way around. So this is how I like to describe to do these. I like to put an arrow where I want the decimal. So what are you gonna put where you want the decimal? An arrow, and then I count. And since they have commas on these, it makes it nice because we can just count by threes, right? So 3, 6. So this would be 3.725 times 10 to the 6th. Right? Where do I want the decimal on this one? After what number? After the 3 also. And we just have to count how many times we had to go over to get there. 1, 2, 3, 4. So this is 3.16, yes, bless you, times 10 to the negative 4. Okay, so there's something kind of weird about this. Do you guys see something weird about this compared to what we just did? Because normally, like this way, bless you, which way are we moving the decimal on this one instead?
Backwards.
Ah, we're moving the decimal, this one to the left. Uh-oh. But then we had to have a positive exponent. And this one we had to move the decimal to the right, and then we had a negative exponent. So how are we going to remember this? Hector, how are you going to remember it?
This is a big number, just say you're redoing it and making it.
Yep, so that's a good idea. So you're seeing this is a big number, and so the exponent has to be positive. This is a small number, so the exponent has to be negative. Is that a pretty good rule for you guys? Can you remember that? Let's try that out. I want you to do D through F, but remember, what are you going to put first to remind you about what you're doing? The arrow. And where do you put that arrow? Right after the first digit. So right there, and then keep on going. So now put these into scientific notation. And when you're done, so right now the decimal is right here, correct? Even though we don't write it, we just know that it's there. So to get it from here to be where I'd put the arrow, I would have to move that decimal over 1, 2, 3, 4, 5, 6, 7 places. So this is going to be 1.414 times 10 to the 7th. And that was a big number, so it's a positive exponent. Do you see what I'm saying now? So this one, where's the decimal going to go after on E? After what number?
8.
After the 8. And this one after the first one. So then these, this one's going to be 8.76 times 10 to the, and we had to move it over 1, 2, 3 times. So it's going to be negative 3 since it was a small number. And this would be 1.14 times 10 to the negative 1 since I only had to move it over once. Good on these? Okay, nice. Now, these last 2 problems, I like them because they're not even that hard. So we are supposed to order this from greatest to least. I want you guys to underline greatest to least. And the nice thing with scientific notation is it lets us do that greatest to least kind of fast because we can look at the exponents. Which exponents, so look at those, just the exponent parts. Which exponents are the biggest? Kyler, what'd you say?
Top and bottom.
The top and the bottom ones. So these are the biggest. So now we're going, the greatest so far. So now we only have to compare their decimals. So which one is greater? 1.03 or 1.06? Which one is the greatest? It's 0.06, right? So we're going to put 1 because that's the first one that we're supposed to do. That means that this one is 2. Good?
Yep.
Now we have the 10 to the 6ths, right? They're the same part right there. So now we compare the decimal parts. Which one's greater? 1.83 or 7.15? Wait, greater?
Oh, 7.15.
Okay, so then we go 3, and then that's going to be 4. And so then I'm going to list that off to the side, and I'm going to list it over here. So the first one is the greatest one, and I'm just going to do the UK. And the next one was Canada. Next one is Mexico. And the last one is India. And what do these represent? What does it say? Look, let's read the words. Yeah. So they come to the United States and they spend their money here. And people from the UK spend the most when they come to the States. Okay, question.
How is Canada the second one?
Because we're comparing 1.06 versus 1.03. Which one is greater? Is 106 greater or 103 greater? 106 is greater. You see that? Okay. So then on the got it problem, what are we do you guys see the typo on the got it? Least to greatest. Okay, so everybody added in the T and the period there.
Greatest. I like greatest.
Least to greatest. Okay. And we're supposed to do least to greatest. So which ones are going to be the least on this one? When we're looking at the table, which ones do we want to do first? Which one's the least? Which powers are we looking to? Power 10 to the what? Everybody show me with your hand. 5. Good. So we're going to compare these first. And since we're supposed to do the least, now we can just compare their decimals. Which one is least? 7.21 or 9.01? Boston. So Boston is the first one. That means that Metro DC is the second. So now we're going to compare the powers of 6, and we got to look for the least between those. So which one's the least between those? Las Vegas has got to be 3, so that means Los Angeles is 4. And what does this represent? This is the number of visitors from overseas travelers. So more overseas travelers visit Los Angeles than anywhere else. Does that make sense?
Yeah.
Or the least visit Boston. So then we put this in order over here. Boston, DC, I'm just going to do DC for short. Las Vegas, and LA. Okay, last part is basically just saying what makes more sense. And these are going to have words. I believe in you and your ability to read. Okay, so it says if you could walk at a rate of 2 meters per second, it would take you 1.92 times 10 to the 8 seconds, which by the way is 192 million seconds, to walk to the moon. Is it more appropriate to write this time like this or just to say 6.09 years? Yeah, because why?
Because it's 6. Oh, because
It-
it's easier.
It makes more sense to talk about that much time in years than in seconds. Like you don't say, how long does it take you to get to school? Oh, 314 seconds. Like you don't say that, right? You're going to say the minutes. Okay. So then you're just going to explain why. All right, your homework. Your homework for lesson 6 is... So you have to do this. You have to do both of these. So let me zoom out. You have to do both of these pages, this side and this side, but you get to skip any one problem. So that means you're going to do 1 through 15, but you get to skip one problem. One problem. Any one you want to. And then 27 through 29, and you have to do all of those. So 1 through 15 all, and then 27 through 29. And so what I'm going to do is, now that we are done with this lesson, we're going to go back and answer questions from any homework that you have not finished, including problems that you just didn't do because you forgot to do. Okay? So let me give you I'll give until 11 o'clock for you guys just to work on anything that you want to gather which questions you have to ask me. And then we'll start at 11.